I'm Ashton Addison from the Crypto Coin Show, and today on Blockchain Interviews with Brendan Farmer, co-founder of Polygon. Brendan, welcome to the show, and thank you for taking the time today.
Yeah, thanks, Ashton. Thanks for having me.
You're very welcome. Excited to dive into the latest updates with Polygon and what Polygon is doing for the blockchain industry overall. I feel like 2024 so far has kicked off to an amazing start with the further increased adoption with the Bitcoin ETF, the halving, potentially more incredible updates for all the layer 2s that are coming out. And I know that there are some issues that need to be solved to really unify blockchain as one holistic ecosystem. And I think Polygon has a part to play with that. So let's dive into the latest updates that Polygon and the team have been working on. I'm really excited to hear the details. Maybe you can talk a little bit about, first I've seen this AggLayer update, and these are some this is a big project. So we might spend some time on this, but I would love to just kick it off to hear what you and your team have been working on this whole time, and then we can dive into all the details.
Yeah, sure. So the aggregation layer, the AggLayer, is a big one for us. We've really been thinking about these sort of the underlying problems for a long time. And just to take a step back, if you think about how we think about blockchain scaling right now, the debate is sort of stuck between the monolithic side and the modular side. And so the monolithic side says, look, when we talk about scaling in crypto, we're really talking about scaling access to liquidity, access to shared state, maintaining composability. If we create a bunch of chains that can't access liquidity where it's sort of available and useful, then we haven't really scaled in a meaningful sense. And so the modular side, on the other hand, says, actually, the way to scale is we'll never be able to bring internet scale crypto with a single chain. Like, we'll always run into bottlenecks. There'll always be contention for shared resources. And so fundamentally, we need to look at a multi-chain approach to scaling. So I think that both sides get something right and something wrong. I think the monolithic side is correct that really what we're trying to do is scale access to liquidity. Like, if liquidity is fragmented, that creates a bad user experience. It creates complexity, but it also creates cost for users because they encounter slippage, their execution is worse. And then on the other side, on the modular side, I think that they're correct that we need horizontal scaling. We need to be able to add block space so that we don't run into this situation where we have like these intractable limits to scaling. But at the same time, like, we need some way of taking fragmented block space and unifying it so that users can access shared liquidity and shared state. And so fundamentally, that's what we've been thinking about with the aggregation layer is how do we take a modular multi-chain ecosystem and unify liquidity and state across those chains?
Yeah, I appreciate that explanation. And I feel like the sweet spot is somewhere in between, right? Because we're seeing chains get really big and running into issues, but we're also seeing so many different blockchains coming out that could probably be working better together to unify the liquidity. I feel like that's very important if we're going to be getting to the next stage of adoption where big money wants to come in.
Yeah, so for us, I don't know if you've ever seen the meme like thesis, antithesis, synthesis. And so for us, like, one way to look at it is the original thesis from Bitcoin and Ethereum, and then for blockchains like Solana, is like the thesis is monolithic. And then the modular thesis arose in response to the limitations of the monolithic thesis. And so for us, like, the synthesis, the way forward is this aggregated thesis where we have a multi-chain ecosystem, but we have the mechanism to unify state and liquidity across those chains.
So maybe you could talk about the vision. How did you guys plan all this out? Because this is a huge initiative to try and unify blockchain together. What was the vision, and how did you start building this aggregated layer in solving all of the different problems without making it too complex?
Yeah, sure. So our I guess the main design principle with the AggLayer is simplicity and minimalism. Like, we want to build a protocol that can support internet scale crypto adoption, and I think in order to do that, we need to build something that's minimal and that's not opinionated and can accommodate like a range of chains running on different execution environments, using different tokens, using different mechanisms for sequencing. And so for us, like I guess the foundation of this vision is ZK tech. And so the question was like, okay, we know that right now for two chains to interoperate, they need to like two L2s. You need to go from your initial L2 to Ethereum and then to your destination chain. So if I want to move tokens from chain A to chain B, I need to withdraw from chain A. I need to wait until the proof of my withdrawal hits Ethereum and that block on Ethereum is finalized. So that's like 25 minutes. And then I need to deposit into chain B. So that's another, however, 12 minutes of latency. And so the concept was like, how do we create low latency interactions between chains in a way that's safe and trustless? And it turns out that we can do that by using ZK tech. So we can let chain A and chain B interoperate however they want to. They can run full nodes for each other. They can use a shared sequencer. They can rely on builders or relays. Like the coordination mechanism is sort of out of scope for us. But what we do guarantee with the AggLayer is that if chain B receives a message from chain A at lower latency than Ethereum, let's say like chain B receives a message from chain A and 2 seconds later wants to start building blocks on that message that they received from chain A, then chain B can commit to the sort of state of chain A that produced that message. And we can use ZK tech to ensure that chain B will never be finalized and accepted by Ethereum unless that block that chain B is relying on from chain A is valid and is also finalized to Ethereum. And so this approach like generalizes to a bunch of different cases, but fundamentally it's about like enabling chains to interoperate at really low latency while still maintaining safety. Like that the destination chain or chain B will never be rugged by anything that chain A does. And that opens up the design space and enables them to coordinate in ways that they currently can't.
Okay. It's a lot to digest, but I know that your team's focusing on the minimalism and simplicity, which is good. And I think people, when they see how it works from a DeFi perspective, if you're just somebody who's going to make a swap or make a move of some crypto coins to another blockchain, they won't have to understand all of this. They'll just be able to have a seamless experience, I would hope.
Definitely not. You will not have to know anything about ZK tech or what chains are doing on the back end. But the sort of interface that we enable is what we're calling like bridge and call. So you can if you have funds on one chain, you can bridge them and call some other contract in like one interaction. And so we think that if you have like you said, if you have USDC on one chain and you want to buy ETH on the chain that has the deepest liquidity, then you'll be able to do that in a really, really simple and user-friendly way.
That's very cool. And now in terms of unifying the liquidity on these different chains, how exactly will that work? Will it be, say there's 20 EVM chains that all have 1 million of liquidity that's not communicating with each other, and that sort of moves into a single pool that's worth 20 million that lowers the cost and the slippage and et cetera?
Yeah. So I think this is a really good question. So I think that there are two ingredients for unifying liquidity. The first is fungibility. So right now, if you think about how third-party bridges work, like if I want to bridge from Polygon to Arbitrum via wormhole, then what I'm doing is I'm locking my ETH, and then I'm minting wormhole ETH on Arbitrum. And the problem is that wormhole ETH is not fungible with regular ETH. I need some liquidity provider to get me from my wrapped synthetic version of an asset to the native version of an asset. And so providing fungibility in the Polygon ecosystem is something that's really important. And the unified bridge and the AggLayer allows us to ensure that L1 native assets and L2 native assets are fungible across chains. So I won't have to think, okay, I have ETH on the ZK EVM chain, and I want to move ETH on the POS chain. I'm not minting ZK EVM ETH. I'm just getting ETH on the destination chain. And so this is a really, really powerful thing for unifying liquidity. to your question specifically, what will the world look like? Will it be a single super deep pool of liquidity, or will it be a bunch of pools that sort of automatically rebalance and have arbitrage opportunities between them, so they effectively have the same execution? I think that is an open question. You can imagine a world in which there's a single pool that has all the liquidity, and the problem is that like getting best execution on that pool and getting priority becomes really expensive, and so normal users might be priced out of using that pool. But one thing that you can imagine is those users would sort of batch their transactions and on low-cost chains, and then that batched transaction would be executed on the pool with deepest liquidity, and so the transaction cost would be amortized across all the users that are batching. I think that there are like similarities between that model and the model that you described, where you just have a bunch of different pools that are all automatically rebalancing and where orders are sort of being routed between them. I think that both are uniquely enabled by the AggLayer and by sort of the vision that we're building, and I think it'll just be interesting to see what dominates.
Yeah, it's very interesting. And I like that example that you gave with bridging through the wormhole. I feel like that is a setback right now, where I don't think you can't really tell from the front-facing perspective, but you may not necessarily have the exact same ether on Polygon that you would on a different blockchain. And same goes for stablecoins as well. A stablecoin, USDT or C, that's on a certain blockchain, it's not the exact same coin on a different blockchain, and that's why the liquidity can't be combined, because it's not the same asset.
Yeah.
Yeah. And I'm curious also on the ZK perspective. A lot of people just know zero-knowledge proofs as something that adds speed, privacy, being able to confirm things with zero knowledge. Are there extra benefits to introducing this ZK tech into the AggLayer, or maybe you can touch on that a little bit more?
Yeah, sure. So ZK tech is sort of it's like the fundamental ingredient of the AggLayer, because we need a guarantee that like we need to be able to prove to Ethereum that we have this giant multi-chain ecosystem with thousands or tens of thousands of chains. And we need to be able to prove to Ethereum that actually all of these chains are sort of like operating on consistent views of the same state. So you don't have like chain A telling chain B one thing and sort of double spending on chain C. And so being able to do what we call proof aggregation is a really, really important thing. And it has like sort of a few different purposes in the AggLayer. It provides a guarantee that everything that happens across all chains is valid. It provides a guarantee that chains are relying on consistent views of other chains' states. And it also provides this safety guarantee where we know that if a single chain is compromised, that attackers cannot drain the entire ecosystem of funds, because we're able to enforce that no chain can sort of withdraw more than the tokens that are deposited in that chain, even if that chain's prover is unsound. And so it's a really important ingredient in this overall vision.
Definitely. And with some of the EVM chains right now, there's so many that are coming out, but from what I understand, some of them have some kind of ZK technology that they're looking to integrate, some of them not as much. When these new EVM chains move into the AggLayer, does that make them all sort of have a unified equal level of ZK technology implemented into the chain, or how does that work?
Yeah, sure. So that's a good question. And it's a timely question because we just announced our type 1 prover, which sort of achieves what you're describing. And so the way that I would put it is, in order to participate in this ZK-powered ecosystem that runs on the AggLayer, chains must include ZK proofs. Like we need a guarantee from each chain that everything that happens on that chain is valid. And so if we think about like what the current state of the world is, we have all of these EVM chains, like optimistic rollups, like Polygon POS, like Alta ones that use the EVM. And there's a ton of liquidity and state and huge user bases that are locked in these EVM chains. And they can't interoperate in the way that we're describing with the AggLayer because they don't support ZK tech. And so what we released last week was the type 1 ZK EVM prover. And this is a really, really cool piece of technology because it allows us to take any existing EVM chain, whether it's an optimistic rollup, whether it's a sidechain like the Polygon POS, or whether it's an Alta 1, and we can instantly start generating proofs for that chain. And so that will allow those chains to onboard into the AggLayer. And so this is like a really, really important component of the overall vision, which is to take all of this fragmented liquidity and state and these user bases that are currently dispersed among a bunch of EVM chains and unify them together so that we can deliver a better experience for users.
Okay, that's great to hear. And with those chains implementing the ZK technology, how easy is it for all of this to be done? Do they just have to flip a switch? Do they have to rebuild the spaceship?
No. So there are no client changes that are required. Like nothing changes for the users or validators or full nodes. We just turn on a prover and we just start generating proofs for that chain. Obviously, if they want to, if they're like an L2 and they want to migrate their L1 native assets to be able to have fungibility with L1 native assets on the AggLayer, they would have to do a bridge migration. But if they don't want to do that, they can just immediately start generating proofs.
Amazing. And so does this sort of came about from the Polygon's growth from the POS chain moving into the ZK EVM chain, and you guys are going to be running both of those chains, but this technology, does it affect primarily the ZK EVM chain?
So it actually affects POS because the POS chain is not using ZK technology. And there's a ton of liquidity. There are a ton of users. I think it's one of the most actively used chains in the ecosystem. And so taking everything that exists on POS and onboarding it into the AggLayer so that all of the assets that are on POS, all the users can seamlessly move between POS and ZK EVM. That was sort of the genesis of the type 1 prover and the reason why we started working on it. So.
That's awesome. And now in terms of the transaction costs, ZK is supposed to help lower the cost too as well. The cost varies from what I've personally experienced in different layer 2s on Ethereum, going from $1 to 10 cents to a few cents. How will this affect the costs of the different chains? Will that be improved even further?
Yeah, sure. So I think it's really important to note that the cost for L2s is generally dominated by the cost to post data to Ethereum. So if you're a rollup, every transaction you have to post some amount of data to Ethereum, and this has a cost. And so generally all of the transaction costs that you see for L2s are based on this L1 data availability cost. And so I think that the way that I would look at it is there are other costs that exist on L2s. And so one really obvious one is that optimistic rollups have this downside where if you want to withdraw from an optimistic rollup via the native bridge, you need to lock your funds for 7 days to sort of wait for the duration of what they call the challenge period. So it allows anyone to submit a fraud proof if the operator of the optimistic rollup is misbehaving, and you can ensure safety. But the problem is that this 7-day withdrawal window imposes a real cost on users. No one wants to lock up their highly volatile crypto assets for 7 days and take on duration risk. And so what they do is they rely on third-party bridges that impose fees on users. And so these fees in aggregate are actually it's a lot of money. So it's millions of dollars. And so the nice thing about the type 1 prover is that we can convert all of these optimistic rollups into ZK rollups. And the proving cost, so we're effectively taking this duration risk and these fees that are paid to third-party bridges, and we're replacing it with a proving cost. So instead of forcing users to pay for bridges, we just force them to pay or to cover the cost of generating zero knowledge proofs for the chain, and so they can have instant withdrawals. And it turns out that the proving cost is actually really, really low. So right now we're seeing proving costs for generating proofs for mainnet Ethereum blocks as like 2 to 3/10 of a cent. And in the next few weeks, we're going to release an upgrade. So this will go down to like between 1 and 2/10 of a cent. And then in the sort of more medium term, we expect a 30 to 50x reduction further. And so, yeah, it'll go to like, I guess like 4/1000th of a cent. And so this like in terms of cost, this is like, orders of magnitude less than the capital and efficiency costs that are imposed by optimistic rollups. And so it doesn't solve the data availability cost, but it does solve these other sort of rollup costs that are still borne by users.
Yeah. Wow, that's incredible to hear. I can't imagine not having to pay $1 or $2. It just gets me so excited, and that's crazy. So your team, this is a huge update, obviously, but then you're going to be working towards even further upgrades that you're talking about that will make it 50 times cheaper and faster in the near future.
Yeah, and I will say, like, from the transaction cost perspective, this model allows us to, and this sort of the AggLayer and the multi-chain model allows us to launch what are called validiums. So they're L2s, but they don't require you to post data to Ethereum. And so for these, like, the transaction costs can be super, super low. And so, yeah, I think in the next like year or two, we'll see a pretty huge reduction in transaction fees.
Very cool. So looking towards the very near future here, is there going to be, what are your teams sort of focused on in the next month or two in ensuring that, this all rolls smoothly and everyone's getting on board and really getting the realization of these benefits for everyone that's using DeFi and on all apps in EVM chains?
Yeah, sure. So the AggLayer is going to be released in a few different stages. So happening this month will be V1, which is effectively a unified bridge. And so this will provide that fungibility property that I was talking about earlier, where you can move assets across chains, but it won't have the low latency property yet. So low latency will happen in a few months, but yeah, so in the near term, it's about providing fungibility, about getting chains using a unified bridge, and then in sort of the medium term, we'll be releasing further upgrades, which will enable the low latency mode for cross-chain composability and interaction that I was describing earlier.
Awesome. I'm looking forward to that. I would love to have the team back on, as the phases develop and we can see just the benefits, people reaping the benefits in these applications.
Yeah, for sure.
And what is the best way for people to follow along? Well, first of all, to learn more about AggLayer and the Type 1 and for these updates as they're rolling out to sort of understand better and capitalize on these improvements that your team's making into blockchain.
Yeah, sure. So you can follow 0x Polygon on Twitter. You can we have Discords for Polygon developers and then an overall Polygon Discord, and so we run AMAs and we're pretty responsive to questions and feedback. And yeah, I think that pretty much covers it. Twitter and Discord.
Sounds great, and I can leave those social links in the show notes below as well. Appreciate your insights into this. Congratulations on making such an amazing improvement to blockchain. I'm excited to reap the benefits myself and looking forward to the coming months as this develops further on. Thank you so much, Brendan, for your time today, and all the best with everything Polygon moving forward, and let's follow up in the near future.
Yeah, thanks, Ashton. Really appreciate it, and thanks for having me.